So today we're going to work 5 problems that involve solving equations with rational exponents. And we're going to devise a method, some steps that we can follow in order to solve any equation that has rational exponents. Notice that this problem has a fraction as an exponent. That's what we mean by rational exponents. And we want to find the value of x. So the first thing I'm going to do is I'm going to raise this power to a power, x minus 5 to the 2/3, and I'm going to raise it to the 3/2 power. The reason I did that is because we know when we raise a power to a power, we multiply. And if I multiply 2/3 times 3/2, I get 1. So this gives me x minus 5 on the left-hand side of the equation. And it simplifies my algebra tremendously. But I also know that whatever I do to the left-hand side of the equation, I must also do to the right. So I must raise 4 to the 3/2 power as well. And when I put 4 to the 3/2 power into my calculator, what I find is that I get 8. You can also do this by rewriting it as a radical and taking the square root of 4 to the 3rd power. You would get 8. So the one thing I do know, and let's go ahead and do that so you can see what's going to happen next. This would end up being the square root of 4 to the 3rd power. And 4 to the 3rd power is 64. So that's the square root of 64. And what we know about the square root of 64 is it is plus or minus 8. We have to include that plus or minus when we have an even denominator here. That 2 requires the plus or minus 8. So we have 2 equations we have to solve. X minus 5 equals positive 8, and x minus 5 equals negative 8. And so if I add 5 to both sides here, I get 13. Adding 5 to both sides here gives me negative 3. One of the most important steps when you solve equations with rational exponents is the check step. Because often we get extraneous solutions and we don't want to include them in our answer. So I'm going to go back and I'm going to first check my 13. 13 minus 5 to the 2/3 power is equal to 4. So this gives me 8 to the 2/3 power equals 4. And I put that in my calculator, 8, and I raise it to the 2/3 power, and I get 4 equals 4. So that checks. If you don't have a calculator, you can just take this 8 to the 2/3 power and say that's the 3rd root of 8 squared, or the 3rd root of 64, which we know is 4. So the result is 13 is one of my answers. It does check. Let's check the negative 3 now. Negative 3 minus 5 to the 2/3 power is equal to 4. So that means I'm taking negative 8 to the 2/3 power, and let's rewrite that as the 3rd root of negative 8 squared. And again, negative 8 squared is positive 64, and when I take the 3rd root of positive 64, I get 4. So both of my answers check. So let's write down the steps, the method that we use to solve this problem. The first step was we isolated the term that has isolate the term with the rational exponent. And I'm going to abbreviate here with the rational exponent. The second step was we raise it to the reciprocal power. And we have to keep in mind that if the denominator is even, we need that plus or minus. The third step is to solve for x. And the last step is check. So now we have a method for solving equations with rational exponents.